viewers, I am requesting you to uploading not to copy from the channel. We are putting in for proving assignment solution, which is also one of the exam solutions. Dear NPTEL learners, please do not note that at least 40% score. Most of the questions come from the assignments. In spite of your busy work, please revise once after watching to get the score. Subscribe now. Hello viewers, in this video we will see the solution to week 2 assignment 2 for the course analog communication. First question, the Fourier transform of Dirac delta function is, we will see the solution. So the Fourier transform of a Dirac delta function is integration minus infinity to plus infinity delta t e power minus j omega t dt. So that will give you the straight line, constant line, which is 1. This is 1 for all frequency. This is 1 for all frequency. So the answer is option. So the answer is option D. Option D, 1 for all frequency. 1 for all frequency. So it's 1 for all frequency. Second question. Let the Fourier transform of a signal x of t is x of f. If the Fourier transform of x of t is given by x of minus f, then the x of t can be. So the answer is C. Option C, both real and complex. So I have taken example for these two example. For rectangle and for exponential, your Fourier transform can be complex as well as real. So answer is option C. Option C. Third one, if x of t is an even function, which of the following statements about its Fourier transform x of f is true? So the answer for this is third question. You can see here this rectangle function is an even function, and this double-sided exponential is also an even function. So which leads to purely real. X of f will be real, purely real. So the answer is option B. Fourth, in order to modify the amplitude response in frequency domain, which of the following quantity is needed to be modified in the time domain? Naturally, it is option A, amplitude. Option A, amplitude. Fifth question, if a signal g of t is given by g of t equal to sin t by t, what is the solution for this? We will see here. So for fifth question, by duality theorem, we know that A sinc 2wt is A by 2w, rectangular function f by 2w. If A is equal to 1, and I can write this as in terms of sin pi 2wt by pi 2wt, and this is A equal to 1, therefore 1 by 2w pi f of 2w. Let me make 2w equal to 1 by pi, so that I will get sin t by t. So and I can substitute this 2w here as well as here by 1 by pi, I will get sin t by t. The Fourier transform, this is actually Fourier transform, not equal to, it's the Fourier transform is pi, it's a function pi, rectangle function pi by pi of pi f. So the answer is option B. Option B, pi of pi f, option B. And for the sixth question, find the energy of the signal. We will see the solution, and if you, from the solution 5, from the above solution 5, we have this function. If you draw this function, it will be a rectangle with a duration of 1 by pi and an amplitude of pi. And by Rayleigh's energy theorem, E equal to minus infinity to plus infinity integration, and we have to square this function after taking magnitude and integrate with respect to df, and which is nothing but if you square this, taking magnitude and square this, that becomes integration is simply nothing but the area under the curve. So therefore it is nothing but pi square multiplied 1 by pi. So if you square this, it becomes pi square, and the duration is 1 by pi. So if you multiply these two, it will get pi. So the answer is option D, pi. Seventh question, let a signal s of t is given by these two constants for negative time and positive time. We will see the solution for this. So solution for this is, answer for this is, so e power minus a minus t. This can be minus t for t less than 0. T is negative, that means, and for this it is t minus at, t is positive here. So for t less than 0, which means t negative, it is e power at. For t greater than 0, t is positive, it becomes e power minus at. So therefore the answer is option A. Option A, A limit a tends to infinity. E power at u of minus t minus of e power minus at u of t. Option A. Option A. Eighth question, find the Fourier transform of x of t for the above question. We will see the answer for this. So for the eighth question, we have taken this one, and we try to find the Fourier transform. You apply by what we find is the Fourier transform of this is for individual value. The Fourier transform is 1 by a minus j omega minus of 1 plus a plus j omega, and of course a is there. And now if you put the limit a tends to 0, this becomes 1 by minus j omega minus 1 by j omega. So therefore what we'll get here is minus 2a by j omega, and now small modification we'll do here, multiply and divide by j and j. So now j square is nothing but minus 1, so minus minus cancels, and you have 2j by omega, because j square is minus 1. So j square is minus 1. It's a simple integration. You can do this one. And the answer is option C, 2ja by omega. Option C, 2ja omega. Ninth question, find the Fourier transform of u of t. It's a similar one. Ninth question, it's a similar one. You can see f of u of t can be defined by 1 by 2 plus 1 by 2 signum function. You take 1 by 2 common, it becomes 1 plus signum function. And the Fourier transform, 1 by 2 is taken outside, the Fourier transform of 1, and you try to find the Fourier transform of a signum function. We know that the Fourier transform of 1 is 2 pi delta omega, which has been already proved, and the Fourier transform of signum function is also proved. It is 2 by j omega. Simply add these two functions, and there is 1 by 2 outside, and therefore what we will get here is the Fourier transform of u of t is pi delta omega plus 1 by j omega. So answer is option C. Option C. So pi delta omega 1 by j omega. Pi delta omega 1 by j omega. Pi delta omega 1 by j omega. Option C, correct? Option C. 10th question, if x of t is equal to x of f, what is the Fourier transform of x of t e power j 2 pi f naught t? So answer for this question is by applying frequency shifting property. It's a property you can find in every textbook. It has been proved. So the answer is option A. It is x of f minus f naught. X of f minus f naught. A. Thank you.